question? Okay. Okay, so our goal today is to multiply and divide rational expressions. We are going to do this quickly, but this is something you probably haven't seen before, okay? Especially if you've come through with the Common Core, unless you came out of Algebra 2. If you came out of Algebra 2, you have seen this before, all right? So let me get to my... Okay, nope, that's not the one I want. Okay, so let's go ahead and have you fill in the blanks on that one, okay? Okay, so what we're gonna start with simplifying. Basically, if you can do simplifying, you can do all the rest of them, because all the rest of them are just one extra tiny little step that you have to remember to do. So once we learn this one, it really isn't that big of a deal to pick up the others, okay? So basically, the simplified form of the numerator and denominator have no common factors except plus or minus 1. That means it's simplified. In order to put a rational expression, and a rational expression is basically a fraction but that has the variables in it, right? It's a polynomial over a polynomial. In simplified form, divide out any factors that the numerator and the denominator have in common. If you didn't know how to factor before, you're going to know now, because you have to factor multiple times in one problem for these, okay? So let's go back to, I don't know, I think it's now in about 3rd grade, okay, where the fractions are. Okay, and let's talk about the factors of these fractions, and let's just practice this for a minute, and then we'll talk about how we do this with variables. What's the greatest common factor of both of those? 5. So the top is 5 times what? 3, and the bottom is 5 times what?
13.
13. Good. What happens with the 5s? They cancel, and we're left with 3 over 13. Okay. You guys tend to like this lesson because we get to cross stuff out, and for some reason when we cross stuff out, that's fun. Okay, feels like we're accomplishing something, we're getting rid of stuff, right? We're cleaning out. It makes us feel good. All right, so the first example here, what is, I don't have to do any factoring, I just get to cross out. Okay, so what am I going to cross out? X plus 1. Good. And we're left with 2 over x plus 3.
You can do that if a 2 is next to the...
Correct. Yeah. Don't resist the urge to distribute, right? We're this one is factored for us. We're going to probably have to factor most of them ourselves, okay? We only can do this, though, if it's multiplications. Let me show you an example. If I had x plus 2 over x plus 3, I cannot do that. Do we see the difference? See how it's multiply? What was this? Add. So you can't do add and subtract. This is a big no-no. All right? Don't do this. Okay? Only when it's multiply.
Yes, ma'am.
All right. Let's look at this one. Is there anything I can cross out just by looking at it?
No.
No. Okay, what is the greatest common factor of the numerator? 4. So I'm going to factor that. So I'm keeping the x minus 5 and the x plus 3. When I take out a 4, what am I left with in the numerator?
X plus 3.
X plus 3.
Big hint. You should probably get something that's going to cancel with one of the denominators. If not, you've probably done something wrong. Okay? All right, what happens?
Cancels.
What cancels?
X plus 3.
X plus 3 cancels, and I'm left with 4 over x minus 5. Done. You like this one? See, I told you guys you would like it, right? It's fun. We get to cross... Yeah, yesterday's wasn't fun. This is much better. Okay? Because factoring's easy compared to what we did yesterday. It goes like that in here. We'll have a day that's hard and the next day that's easy, and then it's hard and then it's easy. So it just happens. All right. Numerator stays the same. What does the denominator factor into?
X plus 4, x minus 4.
What kind of factoring is that? It has a name.
Difference of squares.
Good. Difference of squares. All right. What's going to end up canceling there?
X plus 4.
X plus 4. Technically, what's left in the numerator? 1 is left in the numerator. Good. Okay, let's see what the next couple look like here. Okay. Let's take a look at example 5 then. All right. What can you take out of both the top and the bottom? 10. Good. Okay, everybody do it right now. You try it. Get the 10 out and see if you can figure out what cancels. Okay, did you just take a 10 out of the top? Anybody take out a 20?
Yeah.
Okay. I'll go with the 10 because I'm assuming that's what you did, but we're going to do one extra line probably. Okay? When you took out the 10, what was left behind? 4x plus 2. Good. And when you take the 10 out here, what is left behind? Good. What happens with the 10s? Cancel. Now, if you were looking multiple choice, you may or may not find that as your answer. Okay? They may have factored it completely and took out the 2. See how there's a 2 that's a common factor in there? Which meant they could have taken a 20 out originally. Okay, so it might be 2x plus 1 over x plus 3 when you see the answer. Okay, so I wouldn't probably mark this one here wrong because it is simplified. It's just not factored all the way. Okay, and it doesn't bother me if it's, as long as you have all the common factors factored out if you had it multiplied back in like that. Okay. All right, looking at this one, what kind of factoring do we have to do on the top and the bottom? Magic X, good. So two numbers that multiply to -3 and add to -2.
-3, 1.
Good. So x minus 3 times x plus 1. All right, and then the denominator, two numbers that multiply to -6 and add to -1. -3 and 2, good. So we've got x minus 3 times x plus 2. All right, what's going to cancel? X minus 3, and so we're left with x plus 1 over x plus 2. Can I cancel anything else?
No.
Am I allowed to cancel the x's?
No.
No, why not? It's added, not multiplied. We can only cancel on a multiply. Okay? Alright, let's see what we're doing here. Alright, here's what I want you to try. I want you to try example 7. So skip 6. Okay? Oh, never mind. Hang on.
Just did 6.
We just did 6. We're going to do 7. My PowerPoint is off. The one I'm looking at my notes on is off. So we'll just do so. Let's look at 7 here. Okay. Actually, I still want you to try 7 on your own. Okay? Magic X and difference of squares. Everybody try it and see if you can figure out what cancels. Okay? Just 7. Don't do 8 yet. All right. Two numbers that multiplied to -15 and added to -2. What are they, everybody? -5 and 3. So x minus 5 times x plus 3. All right. What's the denominator factor into?
X plus 3, x minus 3.
Good. What cancels?
X plus 3.
And we're left with x minus 5 over x minus 3. Fun, right? Because we get to cross stuff out. All right. Let's look at the next one. You still need to do the work. Have you noticed how the Magic X has now become like scratch work off to the side? It's a tool we use to factor, but it's not part of our linear written work, right? And it's okay to put it off to the side like that. That's okay. All right? All right. Greatest common factor of the numerator is what? Just 2?
2x.
2x. Take out the whole greatest common factor. Okay? What's left behind?
X plus 5.
Good. All right, I've got a trinomial in the denominator. What am I going to do to factor the trinomial? Good. So 2 numbers that multiply to 15 and add to 16. Good. Do I need a box?
Yes.
Why? It's called a leading coefficient, right? All right. And another hint. Look at this. If I put the 15 and the 1 under there, would I cancel anything? No, so we know we don't have it right yet, okay? So that'll be a clue to ourselves. We messed up. We need to keep going here. And I need to take these guys here from the Magic X and follow them by an X. All right, what times what is 3?
3.
Good. Where does my 3 have to go?
On the side.
On the left side. How many times does 3x divide 15?
5.
5. Good. How many times does 1x divide 1x?
1.
Check it. 1 times 5 is 5. So we've got x plus 5 times 3x or 3x plus 1. What cancels?
X plus 5.
X plus 5.
Good. And we're left with 2x over 3x plus 1. It is easy. So let's change it a little bit. Let's make it a little harder. Just a little harder. Okay, not much. I'm going to add 1 extra step in here. And I know we like factoring, so I thought we'd do it like 4 times in a problem now. Okay? All right, so write that in. Fill that blank in. Okay, so in order to multiply rational expressions, if you want to multiply, you multiply numerators, multiply denominators, write the new fraction in simplified form. Okay? Basically, this is the same stuff we were doing before. Okay? Now, here we started with, instead of having something we would factor, we have some monomials here. So we're going to cross out our x's maybe. So, first of all, how many times does maybe 2 go into 6? 3. Okay. 5 goes into 10 how many times? 2. So I took care of the numbers. And you see how it doesn't really matter? I could just make one fraction bar out of that, couldn't I? Yeah, so it's no different than what we were doing before, except that no, we don't have the binomials, we've got monomials. All right, so I'm going to do 3 on the top, 2 on the bottom. All right, I see, what else do you see that could cross out? I'll use a different color. Anything that just right away crosses out?
XY squared.
What about this x and this x? Can't they go?
Yeah.
Yeah, and what's left behind for our x's?
1 squared. No.
Just for the x's, I have
X squared.
x squared in the numerator. Okay, now let's talk about the y's. Okay? So let's put the y's together here for a second. Hang on. I'll get you in just a second. Be patient. Okay? So I've got a y cubed left here. When we are multiplying, what do we do with the exponents?
Add them.
Add them. Good. So what's y squared times y to the first?
Y cubed.
Y cubed. Now what happens?
Cancel those out.
Cancel those out. So I'm left with 3x squared over 2. Did I get your question answered, Ivan?
Yeah.
Yes. See, you just got to be patient. I wasn't done yet. Okay.
Same way you got the 3 and 2.
We got it. Okay. All right, we good with 9? All right, let's look at 10 too, together, okay? Okay, watch this trick. This is a good one too. So again, this doesn't matter, multiplication's commutative, we could make that one fraction bar, okay? What is 2 times 4?
8.
Can't I just cross those 3 things out? Wasn't that nice?
Yeah.
What's left behind for our numbers then? 7. And I'm going to write a numerator denominator. Let's see what we can do here with that. It looks like I have 1 x down here, right? How many x's do I have up top? 7. So couldn't I get rid of, let me do it in a different color so you can see what's going on really explicitly here. If I got rid of that 1 x, wouldn't this x become a
Squared.
2? Okay. The other way to do it is to subtract the exponents. Okay, we'll eventually see something like that, but it's more fun to just cross out. All right, when we are multiplying this x and this x, what do we do with those exponents again?
Add them.
Add them, so we get x to the
6.
6th. Okay, I'm going to go to another color for the y's. So we haven't done purple yet. Okay, what automatically just crosses out for the y's?
2.
These y's here, right? And then y squared and cubed, what's going to be left behind?
Y.
Just a y, right? So that's going to just go away. So be left. Did I need the denominator?
No.
Not this time. Sometimes I think the monomials are harder than the binomials. Okay, for some reason we tend to struggle more with those. All right, let's take a look at a little bit harder. Well, a little bit harder than it was before a few examples ago. Again, it's just simplifying. I could make one fraction bar and then I've got to do a bunch of factoring. Okay? So it's maybe 3 or 4 factorings. So what could I take out of this first one here?
3x.
I'm going to take out a 3x. Good. What is left behind?
Negative x.
What's left behind for this? 1 minus what?
X squared.
Just x. Right? Okay, I'm going to do a different color for the other one, no, the next one here. All right, I'm going to go to this one next. What kind of factoring is that?
Just magic x.
Magic x. Good. So 2 numbers that multiply to negative 20 and add to 1. Negative 5 and 4, is that right?
No.
5, negative 4. So we've got x plus 5 times x minus 4. I'm going to go to another color so you can really follow what I'm doing. We'll go blue. All right, so this one here, what kind of factoring are we going to do?
Magic x.
Magic x again. So 2 numbers that multiply to negative 5 and add to 4.
Negative 5, 1.
Negative 5 and 1, does that work? 5, negative 1. So we've got x plus 5 times x minus 1. And then this guy here is just going to get written down. Let me go to something else. Oh, light blue maybe. Let's see if that works. 3x. Okay? All right, now let's start crossing stuff out. This has way more that we did, so there's way more to cross out. So what are we going to get? What are we going to cross out? Okay, so I heard x plus 5 and I heard 3x. There's one more, but we got to rearrange it a little bit. Do we see what these, see these, got this one here and this one here are very similar, right? There's a catch to it though. I need to take a negative out of this. So if I take a negative out, that's going to swap my signs, isn't it? Okay, I'm going to go a line and rewrite that. So I've got -1, and I'm going to redo the order on the x, or the 1 minus x to x minus 1 times the x minus 4 that's left over x minus 1. Now what crosses out? X minus 1. And we're left behind with negative x minus 4. Okay. They like to do this reverse thing. Okay, so watch out for that. It's going to happen to you somewhere. Okay. All right, let's see what we got here. I think we're just going to do the multiplying today. Yeah. Okay, let's go a couple more here. What's wrong, Ivan?
I think it's a bit off topic, but what would you do if you have like a negative radical?
In here, you're not going to see it in a rational expression. Okay. We will eventually get to some that were like the i's in the denominator, but we're not doing them yet. Okay. Where? Here? No, we're just going to leave it factored out like that. We're not going to distribute in. You could, if you could distribute in, right? But you're doing more work, and if you messed it up, you'd lose points. Okay, so leave it in the factored form. Does that make sense? Yeah. We don't want you to go too far, so you don't lose points making a mistake going too far. Okay. All right, let's try this one. So again, I've got my 4 factors here that I've got to do. It looks like I only have to factor twice, though, right? So, what is the greatest common factor of this top group? 2x. Good. What's left behind? Good. Do I need to do anything to the x plus 3? No, just write it down. Okay, what kind of factoring is this x squared minus 25?
Difference of squared.
Good. So when we get the difference of squares, we get x what? Good. And then do I need to do anything to the 2x squared? No. Good. All right, let's start crossing stuff out. That's our favorite part. All right, I heard x minus 5. What else?
2x.
The 2 goes. This x goes. What does this x turn into? Just an x. Is there anything else? No. Okay, so I'm left with x plus 3 in the top. We don't tend to like the monomial in the front, or in the back, we put it in the front. X plus 5. Don't try to distribute the x in. Again, we don't want you to make a mistake doing that, because you could write down x squared plus 5 and it would be wrong. It needs to be x squared plus 5x. Okay? It's better to be right on this one. Okay. Let's see where we're going. We've got 2. We're going to try to go through 14. And I'm going to save the last 6 for tomorrow. How's that sound? Okay? And that will leave, if I don't have time today, that'll leave tomorrow for us catching up on homework stamping, okay? And hopefully we'll be able to be on track, because I won't be gone next week on Monday, hopefully. Okay, let's try this little bit different kind of factoring. Okay, so let's see. We've got x plus 5 we're just going to leave alone, right? What kind of factoring do I need to try for this piece here?
X.
Magic x. So 2 numbers that add to 1 and multiply to 1. Does it work?
No.
Nope, so that's factored already. You're going to see why here in a second. All right. Binomial. Are they squares or cubes?
Cubes.
Cubes. So that hasn't gone away. So we're going to do that. We're going to do some cube factoring. What's my sign pattern?
Minus plus plus.
Good. Cubed root of x cubed.
X.
X. Cubed root of 1.
1.
Okay, square the first term. Square the last term. What do you get in the middle?
1x.
1x or just. Do we see why that top thing didn't factor? Yeah, what's going to cancel? Yeah, that trinomial is going to go. We've got x plus 5 over x minus 1. Okay. All right, let's try 14. And then we're going to call it good, and I'm going to adjust the homework. Okay. Ooh, too far. Okay, I've got to factor 4 times. Let's see how fast we can do that. Okay. So, let's start it together and then I'm going to have you finish it. How's that sound? Let's factor this one together and I'm going to have you do the other 3 on your own. So what kind of factoring is that? Nope. Okay, taking out the biggest thing, that's called the greatest common factor. All right, so greatest common factor is what?
6x.
6x. What's left behind?
X plus 30.
Okay, all the others are magic x's. So right now I want everybody to try the 3 magic x's. While you're doing that, I'm going to adjust the homework. Okay? Okay, let's check it. So, 2 numbers that multiply to -2 and add to -1.
-2 and 1.
Okay, so we get x minus 2 times x plus 1. All right, in this one here, 2 numbers that multiply to -6 and add to 1.
-2 and 3.
Do we agree?
Yes.
I heard one person. That's why I'm asking. All right, 2 numbers that multiply to -8 and add to -7.
-8 1.
Good. All right, so this one should be ultra fun because we have a lot of stuff there, right? What goes away?
X plus 3.
X plus 1.
X minus 2.
Anything else? No, that was super fun. We got rid of almost all of it. Okay. That's where I'm going to stop it. Okay? So, if you go ahead, you can look in Haiku. It is posted there. It is a worksheet again. Posted in Haiku. It is that worksheet, but let me adjust it a little bit. That was from last year. We're not ripping anything. So it's going to be, I split it into 2 homeworks, just like yesterday's. So you're getting double points for it. Okay? Practice 8-4 and practice 8-4. Okay? This one is officially going to be 1 to 6 all. And this is going to be 7 to 12 all. So you only have 12 problems tonight. And you're getting double credit for that. 50 points for 6 problems. That's pretty good. Okay, that is pretty nice, right? So, and tomorrow we'll do the last 6 problems. This 13 to 18. Okay? So, and that should make a nice Friday. So when am I going to hold off and stamp homework? Tomorrow. I will do all the stamping tomorrow because we should have time at the end, a lot of time at the end to get that done. Okay? So, you do have a couple of minutes to get started right now. Okay? So go ahead for the next 3 minutes, see if you can get the first problem or 2 done. All right. Caesar, in the front, did we show you yesterday